Hi, chemistry students. Here is a video that's going to go over two of the example problems from your notes. You already watched Miss Weck go over the notes part, and now we're going to do two example problems together. Read example 1. Notice there are some values, like the ones we've been talking about, in the problem. Basically, look for the numbers. The units will give you a clue about what values they're for. Like we just have been talking about pressure, and we know ATM is related to pressure. So I'm going to put those in as pressure 1 and pressure 2. It won't surprise you that you have to read the problem to figure out what the first pressure is and the second one is. The way that it's written out as a sentence will help you figure that out. This says the pressure goes from 2.25 to 1.03 atmospheres. So that tells me it started at 2.25, which is why I put that as pressure 1. The next thing you have to do is figure out for the volume, which one was the initial volume and which volume is missing. It says that the air bubble started when the diver was several feet underwater, and as it rose to the surface, the pressure changed. So this tells me that that initial volume is when the diver had the bubble at 0.75 liters. And I don't know what the new volume is. That's what we're trying to figure out, the volume of the air bubble at the surface, where it's about 1 atmosphere worth of pressure, which makes sense because we talked about how 1 atmosphere worth of pressure is what we usually feel, right? In our classroom, at the surface of the water, that kind of thing. Now we're going to plug those values into the equation that you learned with Miss Weck. So here's our equation, and I'm going to plug those values in. So I'm going to say my pressure 1 is 2.25 ATM, and then my volume 1 is 0.75 liters. And then my pressure 2 is 1.03 ATM. And my volume 2 is what I don't know. I'm going to write it as V2, but if you wanted to, you could call that X if it makes it easier for you to do your algebra. Probably the easiest thing to do is to start by doing the math. In other words, let's do this multiplication. So when I did that multiplication, I got this number on my calculator. I'm not rounding to 2 places after the decimal because if I round and then do some more math and then round, I'll get further and further from my answer. So I'm keeping all of the number, but more than 2 places after the decimal to start. I also have both my units there because units get multiplied just like variables will. So I wrote them both there. Don't stress out too much about that part, but I'll show you where it comes in handy. The next thing I have to do is I'm trying to solve for V2, so I need to get it all by itself. Because this is multiplication on both sides, the opposite of multiplication is division. So I'm going to divide both sides by the 1.03 ATM. So I'm going to take 1.03 ATM, and I'm going to divide both sides by that. And that's going to cancel it over here. And then I'll have V2 all by itself. So I have V2 all by itself on the right-hand side. On the left-hand side, my ATMs cancel, just like if I had X in the top and the bottom. I'm left with units that are L, so liters, which makes sense because I'm solving for volume. And then I'm just going to type this into my calculator. So 1.6875 divided by 1.03. And now I can round to 2 places after the decimal. So my answer is 1.64 liters. The volume increased as the pressure decreased, which also makes sense about what we learned about gas laws, that they're inversely related. So as one goes up, the other one goes down. Or in this case, as the pressure went down, the volume went up. Okay, example number 2 is pretty similar, but we're dealing with pressure and temperature instead of pressure and volume. So take a second and read the problem and see if you can plug in the values to our little table over here. Okay, hopefully that's what you plugged in. Here's the issue with gas laws. You have to make sure that your units match. So in our previous problem, our units did match. We had atmospheres for both of our pressures. That was great. If one of them was in millimeters of mercury or something, we would have had to switch it. And we started with liters, and that means our answer is going to be in liters. And so here we're doing okay. We're starting with atmospheres. So that means our pressure too, when we solve for it, it's going to be in atmospheres. And then we have both our values in Celsius, but here's the other thing. You can use whatever units you want for anything as long as they match, except temperature. Temperature, you have to plug in temperature in Kelvin. So every time in any gas laws problem we do for this entire unit, anytime you see Celsius, you immediately have to convert it to Kelvin. The nice thing about that is this is a relatively easy conversion because instead of doing dimensional analysis, you just get to add 273.15. And if you don't add the 0.15, if you just add 273, that's fine too. But I'm gonna write that right here so I don't forget. And then I'm gonna do that math. Okay, now take a second and plug that into our equation. Okay, we have everything plugged in now. I think anytime you have an equation like this, where you have like division happening, the easiest thing to do is to start by cross multiplying. So that's what I'm gonna do. I'm gonna cross multiply here and cross multiply there, and I'm gonna rewrite it. After you cross multiply, this problem looks a heck of a lot like our previous problem. It looks like this step that we had up here. So now this looks a lot like that. We have one piece we don't know, and then we're gonna start by doing the math. We'll start by doing our multiplication. That's probably the easiest thing to see right here. And then we'll divide both sides by this number. If you want, pause the video for a second and see if you can do that and get the same answer as me. If not, I'm gonna talk through it. So first I did that multiplication. Notice I have both my units written and I multiplied them just like I did previously. Looks a little bit weird. There's no such unit as like ATM times Kelvin, but that's what it looks like for right now, because now we're gonna divide both sides by 298.15 Kelvin so that that'll cancel and then we'll have P2 all by itself. So we're gonna divide by 298.15 Kelvin. This is going to cancel here, and then we'll have that P2 all by itself. On this side, the Kelvin will cancel, and we'll have units of just ATM, which makes sense because we're solving for a pressure. We're trying to find pressure too. So now we just have to divide these two numbers. And when we round to 2 places after the decimal, we get 4.41 atmospheres, which also makes sense because our temperature went down, and so our pressure had to go down too because they're directly related. Pressure and temperature are directly related. Ms. Weck showed you that in the previous video, and also we learned that when we are working with the flasks in class. When you put it in the cold water bath, the pressure fell below 100 kilopascals, which was what it started at. And then when you heated it up, then the pressure went higher than 100 kilopascals. So we know that pressure and temperature are directly related. So one of the things you want to do when you do a gas laws problem is also see in the end if your answer makes sense based on what you know about direct or inverse relationships. And then you can figure out if you just made a silly math mistake. At this point, try doing some of the active chem problems. Make sure you show all your work on the document that's provided for you.